Returning to the text, one way to do this is to standardize big Y bar so that it has a mean of 0 and a variance of 1. This process leads to examining the distribution of the standardized version of big Y bar and open big Y bar minus mu sub big Y close over sigma sub big Y bar. According to the central limit theorem, this distribution should be well approximated by a big N of O and 1 distribution when N is large. The distribution of the standardized average open big Y bar minus mu sub big Y close over sigma sub big Y bar is plotted in figure 2.9. For the distributions in figure 2.8, the distributions in figure 2.9 are exactly the same as in figure 2.8, except that the scale of the horizontal axis is changed so that the standardized variable has a mean of 0 and a variance of 1. After this change of scale, it is easy to see that if n is large enough, the distribution of big Y bar is well approximated by a normal distribution. See figure 2.9. Figure 2.9, distribution of the standardized sample average of n Bernoulli random variables with p equals 0.78. Figure 2.9a, n equals 2 on the vertical axis, 0.0 to 0.7 on the horizontal axis, negative 3.0 to 3.0. Figure 2.9a is standardized value of sample average. B is n equals 5, standardized value of sample average. Figure 2.9c, n equals 25. The probability scale has fallen from 0.0 to 0.25, and in D, n equals 100, and the probability has fallen scale. The probability scale on the vertical axis has fallen from 0.0 to 0.12. The horizontal axis has remained the same. The sampling distribution of big Y bar and figure 2.8 are plotted here after standardizing big Y bar. Standardization centers the distributions in figure 2.8 and magnifies the scale on the horizontal axis by a factor of square root of n. When the sample size is large, the sampling distributions are increasingly well approximated by the normal distribution, the solid line, as predicted by the central limit theorem. The normal distribution is scaled so that the height of the distribution is approximately the same in all figures.